In this video, we're going to learn how to find the absolute maximum or absolute minimum value of a function over a given interval. To see how we do it, let's look at the graph of some function called f of x. All right, so this is the graph. Now, so this graph is over interval a to b. By absolute maximum, we mean the largest function value over the entire interval a to b. All the values compared, the largest one. From the graph, what it means is the y-coordinate of the highest point. So we can see it will be here. The maximum value is attained at the location, let's call this location as C3, all right? The y-coordinate of this point. Well, the absolute minimum would be the smallest among all the function values from a to b. So we can see this case, this graph, it will be here. The difference, well, we can see is maximum is attained at a point between a and b. We call the interior point. While the minimum is attained at one of the two endpoints, say at ends. All right, remember that. So what does this graph tell us? Well, we notice there are some points that are special, like the C1, C2, C3 mark here. Why is that? They are special because we kind of can imagine a horizontal tangent line. So in other words, if we draw a horizontal tangent line, if we draw tangent line at a location C1, C2, or C3, we kind of see they will be horizontal. All right. Let's translate to derivative is 0. Okay. So those locations are special. How are they related to our maximum minimum? Well, if we analyze all the function values to find the maximum minimum, we pretty much just kind of need to analyze the function value at these special locations, or we call it critical locations. Because any other value like here, you have a values greater than that on the right side, you have values less than that on the left side. So if you pick up a location here, that's not interesting. It's never going to be maximum or minimum. Well, on the top, there's a possibility this could be maximum because everything around it, right? Every other value around this value is smaller than this. This could be potentially maximum, or let's call this for now like a value of interest. So at C1, C2, C3, those values are what I call the values of interest, because like here, for example, right, this value is smaller than all the values around it, close to it, right? So there's a chance this could be a minimum value. Any other values, not very interesting. And the endpoints, at two endpoints, the value are kind of interesting because this is like what I actually will call later on like a local minimum. It's smaller than all the values close to it, and here that's also kind of like a local minimum value. So if we use the terminology as we'll learn later on, actually it's better to borrow this terminology and use this terminology now to better describe how we are going to go about finding the overall or absolute maximum minimum. So we look for this is like a local maximum, local minimum first. Like this location is like locally, right? The highest point, therefore value here is local maximum, local minimum, locally smallest, locally largest. So only this local maximum, local minimum can be possibly the global or absolute maximum minimum. So we need to find them first. As this graph suggests, all we need to do is to grab all those like a possible local minimum, possible local maximum, and value at ends. Of course, when we do these problems, we're not giving graph, so we would just do it, in the dark. That's why it's important to come up with a workable strategy to do it right, to find the correct answer. Well, looks like it's not too bad. We just need to locate those special locations. End points are always given, so we don't need to worry too much about that. So the strategy is to find those critical locations, C1, C2, C3, and then evaluate the function at the critical locations at endpoints. Just compare. The largest is going to be the global. Of course, without the graph, we would have no idea local minimum, local maximum, but it works as long as we grab all the values of interest and compare. Okay, so this kind of method involve finding the C1, C2, C3, and we're called critical points for now. So f prime is 0, derivative is 0 because slope of tangent line is 0. The tangent line is horizontal, therefore slope is 0 or derivative is 0. So this gives us idea how to find this C1, C2, C3. There are other critical points that we will talk about later on. Just for now, we can see this locations where we can place horizontal tangent line are critical or crucial. We need to find them. Okay, so summarize the strategy to find the maximum minimum value of a function over a given interval. We need to first find the C1, C2 by finding what we call critical point first. Find the critical point C1, C2, C3 between the interval. When you solve this equation, you may find the critical values that are outside the interval, maybe less than A or maybe more than B, and that's not needed. We would discard those guys, right? Because all we care about are locations between A and B. Okay. So find this C1, C2, C3, evaluate the function at the C1, C2, C3 and A, B, compare, and we can tell maximum minimum right away. Let's see example. So let's find the absolute maximum minimum of this function over interval -1 to 3. All right. First, find critical points in interval, within interval -1, 2, 3. That's the given interval. So how do we do that? Well, first of all, we can set the derivative to 0. So what's the derivative? F of x, f prime is 3x squared minus 12x. That's derivative. So we set to 0. Now it's a simple algebra. We find 0, 2, and -2 as solutions. So those are what we call the critical points. So set the derivative to 0 and solve. Now let's check. There are 3 solutions or 3 critical values, but -2 is outside the interval. -2 is on the left side of -1. It's not within the interval, so we're going to discard this guy. All we need to do is to, then step 2, evaluate the function at critical point 0, critical point 3, no, 2, sorry. 0, 2. There's this is what I call it, like a C1, C2. We'll find the 2 of them. And function at the -1, that's endpoint. Left endpoint at +3, that's the right endpoint. So how do we do that? Oh, just basically plug in the x value for x here. So for example, 0 plug in for x, that's 0, 0, that's 5. F at 0 is 5. F at 2, again, plug in 2 for x. This will be 8 minus 2 plug in, that's 4, 24, plus 5. The value is -11. Next, plug in -1 for x. -1 for x, this is a -1, -6, plus 5, -2. And finally, plug in 3 for x. So it'll be 27 minus 6 times 9. 54 plus 5 equal to 22. Okay. So again, make sure you know this is a critical point f of x at critical point, where this is f of x at endpoints, right? Those are the values of interest. Now, compare all the values in this step. What do we find? There is a 5, there's a -1, there's -2, 22. Then we say, we can see this is the maximum. Well, this is the minimum. Okay, it's pretty simple. So 2 steps. First step, you find the critical points by setting the derivative of function to 0, solve. So you find the solutions. Make sure you discard those that are not inside the interval. Part 2, evaluate the function at the acceptable critical points that are inside the interval. Okay, they're all inside. And also evaluate the function at the endpoints. Compare function value. Then you can see which one is the largest, which one is the smallest, your absolute maximum, minimum. Now let's officially define critical points of f of x. Critical points are not just locations where we can place horizontal tangent line. There are also the critical points also include locations where we cannot place tangent line at all, or derivative is undefined, cannot find the derivative. And this is the definition. So we already talked about this type, where the derivative is 0. And then there's another type where derivative is undefined. Graphically, what it means is you have a graph, like I say, that's where you can place horizontal tangent line. That's a critical point. You can call it C1. You could have a graph coming down, then there's sharp corner here. This is a location where you cannot place horizontal tangent line. If you do derivative, you find the derivative is a derivative, sharp corner. So that's a critical point too. And this would be also interesting location, because you can see from the graph, it could be potentially smallest function value, because any other value close by are greater than the function value here, right? So that's why it's also critical. Anyway, just mathematically, it's pretty simple. To find all critical points, we set the function to 0 to get the first type of critical points. And if the derivative is a fraction, we would set the bottom to 0 and the top to 0. So in a fraction, if your f prime is a fraction, like px over q, then basically when you set p equal to 0, you would get the first type of critical point. And you set the bottom to 0, you get the second type of critical points. Because if your number is 0, derivative is not defined. All right? Don't need to do anything else. So all from the derivative. So let's see one example. Let's find critical points of f of x equal to x to the 3/5 power times 4 minus x. All right. So here I already find the derivative. So to find the derivative, you would do the product rule, simplify, all the algebraic work involved. But anyway, just to simplify the presentation, get to the point. Let's say we already find the derivative. Okay, this is a derivative. So according to our definition, we're going to set the top. Set the top to 0. Solve. And you can see the answer is going to be, well, 12 over a, or 3 over 2. Move ax over, divide by a, then cross out 4 from top and bottom. So 3 halves is a critical point. We also, in this case, need to set the bottom to 0. And then we find 0. 5, you don't touch it, it's a constant. So just this part, you would raise, for example, say you divide by 5, you would have 2 over x raised to 2 over 5 raised to equal to 0, and then raise both sides to 5 half power, and then the left side becomes x, and the right side is 0. That's why you get 0. So anyway, for this function, we find 2 critical points. This is where f prime equal to 0. This is f prime undefined. Both are critical points. Okay, so when your derivative is a fraction, set the top to 0, set the bottom to 0, and solve. All right, let's stop here.